Hello everyone and welcome to today's webinar. In today's webinar, we'll be covering the Fronius Tauro, which is Fronius's cost optimized commercial inverter. Your presenter today will be myself, Byron Kutzer. I'm the technical sales advisor for the Southern African region. And joining me today is my colleagues, David Mongi, who's the technical sales advisor for the Eastern African region, and Cipriano Kulu, who's our TSA or technical sales advisor for the Western African region. So in today's agenda, we'll do a short intro, followed by an overview of Fronius solutions for commercial systems, as well as plant design and the choice of inverter, system design and layouts, installation, wiring, and design tools, data communication, export limitation, commissioning, the service component exchange, the Tauro configurator, and lastly, further information will be provided at the end of the webinar. Before we start, please feel free to ask questions during the webinar in the chat box, and we will attend to your questions as soon as possible. And lastly, your opinion is important to us, so we will greatly appreciate your opinion on our Fronius webinar. So the solution for large-scale PV systems. So this allows for maximum flexibility in terms of system design with minimal overall system operating costs, which is why we developed the Fronius Tauro inverter, which makes large-scale PV systems even more cost-effective, whether under direct sunlight or in extreme heat. Its double-walled housing and active cooling enables full power and maximum yields even under the harsh environment conditions. So the Fronius Tauro Eco is available in two different power classes, which is 50 kilowatt and 100 kilowatt. You've got a single MPPT tracker on the unit, as well as an MPPT voltage range, usable range of 580 to 930 volts. And the unit weighs approximately 74 to 103 kilograms, depending on the power class that you are using. We then have our Fronius Tauro Standard. So this is known as in the power class of 50 kilowatts, and it has 3 MPPT trackers and has a different operating voltage range of 400 to 850 volts and has approximately weight of 92 kilograms. So what makes the Tauro so special? Easy installation, as it is one whole unit that has a power class of 50 or 100 kilowatts. Extremely robust for unprotected outdoors. So you can install it, let's say, on a roof, for example, or exposed to harsh environments. The cost reduction due to the flexibility system design, so you can either have it as a pre-combined or direct variant, for example. The AC daisy chaining option, which will allow you to reduce costs by using of a single AC cable running from your last inverter through to your main DB. Your system monitoring hardware, which is on board built in, which is known as our pilot card, which is integrated into each Tauro unit, and also allows for easy rapid service. So the Tauro is designed to be repaired on site, for example. So the power stack, if it is faulty, it can be replaced by 2 personnel on site and not having to remove the unit entirely. So next we'll cover is the Fronius Tauro when you're using your PV plant design. So total cost, so you get a capital expenditures, or known as CapEx, which is normally combined with your operational expenditures, which is your OpEx, which normally gives you your total cost of ownership, or TCO for short. So your CapEx normally consists of your PV module costs, your labor costs, as well as your BOS, which is your balance of system cost. And this will give you an inverter of just plus minus 9% of your total CapEx costs. For your balance of system costs, this will normally consist of your mounting frame, AC and DC cabling and combiners, as well as cable trays, and also your mains connections. So typically this allows for the greatest saving potential, as it is only 21%. The planning approach on commercial systems is normally classically done by the choice of inverter, your costs, so your cents per watt, as well as the choice of inverter, so the power class you're using, the selection of additional cost-effective components, and as well as your distance from the PV generator to the transfer. Whereas the Tauro is the opposite way around, because it allows you for direct or pre-combined system design for your system. So next we'll be covering is the different design topologies for the Fronius Tauro. So you've got two different designs, which is our central design system as well as our decentral system design. So the design of flexibility on the DC side. So with the central system, which is our pre-combined version, you have integrated V clamps on the DC side, which allows for a cable cross section of up to 95 millimeters squared. Whereas on the direct system design, so this is our direct version, it has integrated MC4 connector plugs for direct connection of the module strings, and this also utilizes string fuses, are then integrated as standard. We also have our cost effective on the AC cabling. So again, this allows for lower cable costs due to the interconnection of the Tauro devices on the AC side. So this allows you to do a maximum of 200 kilowatts interconnectable between two different Tauro units. So you can either be doing 2 by the 100 kilowatt variant or the 4 by the 50 kilowatt Tauro variant. Again, it's mentioning more on the AC daisy chaining, so the comparative examples. So this is an example without an AC combiner. So this will be a Tauro direct connection, which is using a 240 or 120 millimeter squared, and has two AC disconnects at the transformer, which is of 160 amps. Whereas if you're doing the installation with the AC combiner with it, so it's 120 millimeters squared combiner or 240 millimeters squared transformer, and then having one AC disconnector at the transformer itself, rated at 320 amps, or by utilizing Fronius's AC daisy chaining, which allows for the Tauro AC daisy chain for 240 millimeters squared between the units, and then allowing for one AC disconnector at the transformer of 320 amp ratings. So with the Fronius Tauro, you also get a flexible choice on the AC side. So again, it allows for low energy losses and maximum power either using copper or aluminum cable is possible. So you got an option for a single core, which allows for 5 inputs and has different variation size possible. So there's anything from 10 to 28 millimeters and allows for easy handling and installation, as well as doing an option for the multi-core, which again is one cable input. So this is anything from 16 to 61.4 millimeters and allows for one bunch of conductors. The next option is for your integrated AC disconnect. So this again is an optional integrated into the unit as standard, or it's configurable and ordered by factory itself. So this is available for the AC options, so either as a single core or multi-core AC input. And then when working within the device, so it allows you to do an AC disconnect, so switch off on the off position, for example. The Fronius Tauro also allows for AC and DC SPD type 1+2. So this allows for its monitored and integrated on the DC over voltage protection. So no additional box is required. So the SPD +1+2 is integrated in the device, and it's optional to have the SPD type 2 fitted. So it's a high quality SPD, so it's exchangeable and feedback contact on the data communication unit, and as well as allowing for individual SPD components can be exchanged on the Tauro. With the Fronius Tauro, we also integrated our arc fault detection, or AFCI. So this allows for maximum safety, so precise detection of AC arcs, and the functional principle according to the IS stack certificate is pending for it. But this allows for us to do a trained algorithm for continuous improvement, and obviously many years of experience with arcs from business unit Perfect Welding since 1950. Additionally, with the AFCI, it's currently available for the Tauro 50, 3 MPPT variant with the option of 20 amp fuses, or the Tauro Echo 99 or 103 with the direct variant with 20 amp fuses. So you can have it as an option from factory itself. So existing Tauros cannot be retrofitted. This is fitted from factory itself when the unit is purchased. So the activation via the user interface of the inverter. So this allows you to do a country setup code is required and can be easily requested via Solar SOS, and simple configuration for the Tauro in our Tauro configurator. So if you are wanting to make use of the AFCI, you can order it from our Tauro configurator tool. Next, we'll be talking about is the layout design flexibility with the Fronius Tauro. So again, mention you have the D option, which is our direct variant, or decentral system design. So this allows for a number of integrated MC4 connectors. So on the Tauro 50, you've got 14 string inputs from your strings itself. And on the Tauro 100, you've got 22 string inputs. And on the smaller 50, which is the 3 MPPT input inverter, you've got a maximum of 14 strings that can be utilized on the unit. So again, mentioning the Fronius Tauro and the Eco. So the 50 only allows for 14 strings. The 99 and 100 is 22 strings. And the direct connection of the strings to the inverter itself using MC4s. So this is either available as 20 or 30 amp fuses, and the correct dimensioning of the fuses. So max is 12 amps per string. For the string, 20 amp fuse are necessary, and a maximum of 22 amps per string when utilizing the 30 amp fuses is necessary. We also have brought out our 30 amp fuse option. So it's a new fuse print with 30 amp fuses and less string inputs. So it allows you to do a 22 amp MPPT current, so your IDC max per string, and also with your 30 amp short circuit current, so your ISC for your max strings. So it allows for the same amount of AC disconnects, but obviously changes the number of strings based on the 30 amp or 20 amp that you are using on the fuses. The optical device differences. So how do I visually recognize a Tauro 50 3D, for example? You'll have two DC disconnect switches located on the front of the unit, and also the 14 MC4 plugs underneath the unit. And lastly, the AC connection point. So you'll have AC daisy chaining as an option. So it allows for 2 by the 5 amp cable glands from the unit. Next we'll talk about is the Fronius P version, so the pre-combined or central topology. So this allows the inverters of the system to be placed near the feeding point, which then allows for longer DC cabling, which is much more cost efficient, and as well as doing the optional DC connection boxes and connection sets are necessary. So it's just showing an example of how you would typically do a central topology system design, where you'll have longer DC runs and shorter AC runs to your main feed-in transformer. So again, how do you differentiate between the variants? So you'll have two disconnects on the switches itself on the front of the unit, and this has integrated V clamps. So you've got 2 by 2 connections, so it allows for up to 6 cable glands. And on the AC connection side, you'll have a single core option. So it's 1 by 5 cable glands for this different variation of the Fronius Tauro. On the DC cable connection point, so this is referring to the Fronius Tauro pre-combined or P variant. So this is the use of string collector boxes and allowing for cable cross section coming into the inverter from anywhere from 25 millimeters to 95 millimeters squared, and a torque requirement of 32 when fixing the cables into the unit. I will now be handing over to my colleague, David Mongi, who will now be continuing.
All right. Thank you, Byron, for the first part. I'll now take over and do the second part of the webinar. So just a moment. And we will be continuing with the layout examples. So in terms of the layout examples, already briefly mentioned by Byron, we have several topologies that are possible with the Tauro inverters. So in this first example, we are looking at a 1 megawatt PV installation, which is a free field. And we can see that this is an area that is measuring about 100 meters square. And the attributes of this topology or this layout is that we have Tauro D, so this is a direct version with AC daisy chaining. So AC daisy chaining, as you can see here, we are able to loop AC power from the first inverter to the second inverter. So therefore, here we are greatly minimizing the AC cable runs. And therefore, the advantages we have with this topology is that we do not require additional DC combiner boxes. As you can see that the PV strings will be connected directly to the inverter using the MC4 plugs, as already described by Byron. And we are going to have shorter AC cable cost. Therefore, the costs are going to be lower. So, and then in terms of the installation effort is much less, because you can see that because of the less distance of cabling, we are not going to have to do a lot of AC cable management from the inverters to the distribution board and onwards to the transformer, for example. Another example is a central topology. So we have a layout on 150 meter by 200 meter field. So this is a free field installation as well. And this is showing an example of a 2 megawatt peak installation. So the advantages we get here is that because the inverters are centrally located, you can very easily access the inverters, especially for commissioning and as well as service. But we also have the advantages that we can run long DC cables. So as we know, you might get lower cost for DC cabling compared to AC cabling. And because of the relatively higher voltage on the DC side, which is maximum 930 volts MPP voltage, we can run relatively long distances without incurring big power losses on the DC side. And therefore, this gives you the flexibility that you're able to position the inverters as close to the transformer station or the distribution point as close as possible to that. So we also have the possibility to do a combination of the two, that is the decentral and the centralized topologies. So in this layout, we have, for example, part of the array that is installed on the roof. So, and then we also incorporate the AC daisy chaining, and we can have a combination also of a partially free field kind of installation with a separate inverter. And therefore, we are able to combine both the attributes of the decentral design as well as the central design, and be able to sort of leverage on the cost of the balance of system, especially the AC cabling in this case. So when it comes to different orientations, because as mentioned, the Tauro Echo 50 and 100 kilowatt have 1 MPPT. Some people would ask, is 1 MPPT enough if you have different orientations? But the answer, as you're going to see, is that you can use an inverter with 1 MPPT without having any power losses on the DC side. So this is a typical production curve during the course of the day. So this is the power and time curve. So we can see that our peak production is around midday in most places. So, and this kind of orientation mixed up between east or west gives you higher self-sufficiency and allows you efficient use of space, and therefore generate maximum PV power. So if there is a very intricate kind of roof design, so that some part of the array is shaded, or if you have very steep inclinations for some of the strings, we do recommend that you split up the PV installation and use smaller devices so that you are able to maximize production on the entire area where the PV system or the PV array is going to be mounted. If you look at the impact on the maximum power point for the east-west orientation, we can see that at optimal irradiation, which is 1000 watts per meter squared, we have our maximum power point at this point. So it doesn't seem to run away too much. So this would be this straight line at which we are going to get maximum power, other than when the irradiation starts to go below 600 watts per meter squared. And therefore, the east-west orientation doesn't really have a big impact on the use of an inverter with 1 MPPT, unless of course you encounter some shading or very steep inclinations, as we have mentioned before. So we have some design rules when you are going to do an east-west orientation for a PV array. So the general idea is that this can be done only on 1 MPPT. So this gives you a cost-effective inverter, and over-dimension is of course possible. And if you look at the mismatching losses because of this east-west design, these are actually negligible, only if you obey these design rules. So number one is that the number and type of modules must be identical in all the strings, and then ensure that you have no shading, and all modules within the same string must have the same inclination. So if you obey these design rules, then your east-west orientation, even when using an inverter with only 1 MPPT, will have minimal mismatching losses, or negligible in this case. So let's look at the cabling options and power loss calculations. So the question is, what cable lengths are possible with the Tauro, for example? Yeah. So we want to know what is the maximum AC cable length that can be achieved when you have a 240 millimeter square cross-section cable on the AC side and a Fronius Tauro 100 kilowatt. And you want to keep the losses at below 1%. So taking into account that we want to keep the losses at below 1%, the maximum AC cable distance that can be achieved in this case is 125 meters. However, systems are usually designed for about less than 3% power loss, but there are no normative requirements that would prohibit an interpretation that is slightly higher than 3%. So this would largely depend on what are your project requirements. But as you can see here, that if we give it a very low power loss or DC or on either side, especially the AC side, we can go to a maximum of 125 meters using the 240 millimeter square cables for the Tauro 100 kilowatt. So when it comes to the selection, so as mentioned already, we have the two variations that are possible for the Tauro inverters. So we have the direct and the combined versions. So we want to know at which point do you go with the direct, and at which point then do you say a pre-combined inverter is better. So in this comparison here, we are considering the total system cost, including losses, over a period of 20 years. So we can see this is a cost analysis for a 100 kilowatt PV block. And then on this scale, we are looking at a distance of from 0 to about 100 meters. So the intersection point would then tell you which inverter to go for you to be able to minimize on the cost implications of using either of the two variants of the Tauro inverters. So the red line here represents the use of pre-combined inverter, and the dark or gray line here represents the use of a direct version of a Tauro inverter. So we can see in terms of the cost, when the distance is below 50 meters, the cost of using a pre-combined version, so this means in addition to the connection, you need also the DC combiner boxes. So that is why the cost here might be slightly up. But the cost of the direct version is lower than using the pre-combined version up to 50 meters. However, as the distance starts to increase and goes beyond the 50 meter threshold, we can see that the direct version, the integration cost of the direct version goes up, whereas the integration cost of the pre-combined version is actually lower. So in this case, as you can see, for the free field installations, like the examples we have looked at, the 1 megawatt and the 2 megawatt, we already have a field of about 100 meters square or 150 meters square. So therefore, for this kind of installations, it might be better to go with a pre-combined version. But probably when you're doing a rooftop installation, where the distances between the PV generator and the distribution board or the transformer could be less than 50 meters, then it's much better to go with the direct version. So therefore, in terms of the most profitable version or the variant, we are going to say that this depends on the distance between the PV system and the main distribution point, as well as the component prices, such as pre-combiner, DC combiner boxes, and stuff like that. So therefore, the direct version for shorter distances, just like said, and the pre-combined version for longer distances. We also want to look at what AC daisy chaining brings into the picture. So this is always more profitable at the total cost level and is the best option for you to be able to save on the AC cable lengths, so the cost associated with that. So when you're looking at the return on investment as your most important attribute, then AC daisy chaining becomes very, very attractive because it ensures you have lower investment costs. So as already mentioned, we can interconnect maximum 200 kilowatts of AC power using the Fronius Tauros. And therefore, this means that for the 100 kilowatts, you can have 2 inverters, and for the 50 kilowatt inverters, you can have a combination of 4 of them. So in this case, we can see that instead of running a cable from the first inverter over the whole distance of 100 meters to the main distribution board, we are able to daisy chain the power, the AC power from the first inverter into the next inverter, so that the only considerable cost of AC cabling from the first inverter is only 50 meters instead of the whole 100 meters, which therefore allows you a lot of savings for AC power cabling. So in terms of the advantages of the direct version, just to repeat it, briefly touched on by Byron as well. So this is a topology that is best for a decentral system that you connect your PV strings directly to the inverter. We have DC fuses integrated into the inverter, and it offers very easy connection of PV power into the inverter using the already integrated MC4 plugs. And in this case, we do not require DC combiner boxes. So what you can see is that we are going to run a much longer distance with AC cabling into the AC combiner box or the distribution board. Whereas for DC power, we are going to minimize on the distance that you're going to run with that. When it comes to the P version, this is for centralized design topology. So the main attribute is that we can have very long DC cabling. So after this, the DC combiner boxes using approximately 700 up to 800 volts on the DC side, we can run a relatively long distance to the inverter on DC power. And we can use here both aluminum as well as copper cables. And the maximum cross section is about 95 millimeter square cables. So when it comes to the installation of the Fronius Tauro inverters, we have to look at the installation instructions and abide by them so that we have a trouble-free installation. So what you need, therefore, for installing the Fronius Tauro inverters? So in terms of tools, you basically need your Torx screwdriver, and this is T20 or T25. And if you're going to use a cordless screwdriver, we recommend only using ones that have torque adjustment possible. Otherwise, if you use a normal one without torque adjustment, it's quite possible that you're going to destroy the threads for the screw areas of the inverter. Then, of course, you do require the quick start guide, and this can be also downloaded from the Fronius website. But when you get the Fronius inverter, it comes with a quick start guide in the package. And the next thing you need is the commissioning app. So this can be a phone app, or you can also go by the browser version of the commissioning process. In terms of the choice of location, this inverter can be used both outdoor and indoor, but it's very robust and designed for outdoor applications. So just ensure that you install it on a solid, non-flammable surface. And in terms of temperature tolerance, the Tauro can be operated from -40 degrees up to +60 degrees Celsius. And this is ambient temperature. But when you have an AC disconnector or isolator integrated into the AC connection area, the inverter can only be operated from about minus 30 degrees Celsius, but I don't think this would be a problem in most places. In terms of the choice of site, so as we said, can be done indoor or outdoor. Because of the double wall concept, this inverter can be exposed to direct sunlight without reducing the power production. But if you have a bit of shelter, even better. It's IP65, so it does not get affected in any negative way by dust or rainwater. Other places that are not recommended. So in terms of altitude, just to mention, you are required not to go above 4,000 meters above sea level. So this inverter is not suitable for higher altitudes than 4,000 meters above sea level. But if you have some specific use cases, maybe the best thing would be to get in touch with Fronius tech support so that you can be guided on what is required in terms of especially the DC power reduction. And then all these other places that are crossed out are not recommended for installing the inverter. In terms of the positioning of the inverter, as mentioned, you can do a surface mount, a wall mount. So you just make sure that the wall has sufficient load bearing capacity, as well as it's not something that can catch on fire easily. For pole mounting, this is also possible. So this can also be done directly behind the PV array or on the poles of the PV mounting structures. It can also be done on flat roofs. If you are going to do an installation for like a rooftop installation, you can have the Tauro directly mounted on the rooftop without any problem. So the only thing then you would need are the optional floor racks. So this would allow you to have a horizontal installation on a roof. So this can be ordered as an option when you have ordered the Fronius Tauro inverter. So by design, the floor mounting racks would be slightly inclined so that water does not accumulate on top of the inverter. So, and then you have also to secure the floor mounting racks on the floor. And of course, this has to be done with some screws that you supply yourself because this is not in the scope of supply. In terms of the distances that you have to observe with the Tauro inverters, so because of active cooling especially, you have to maintain a minimum of 50 centimeters. This is also 500 millimeters all around the inverter. So, and then in terms of mounting, use at least 4 screws. And because of the weight of the inverter, it's recommended, especially for the Tauro 100 kilowatt, to have at least 3 people for the lifting of the inverter to the mounting bracket. So one of the key attributes that makes the Tauro inverter very ideal for outdoor application is the active cooling technology. So this allows or guarantees more yield regardless of the ambient operating conditions. So in addition to the active cooling, the Fronius Tauro inverters have the double wall concept. So the front cover is sort of housing another cover behind it. And therefore, because of this design concept, this inverter is able to give you maximum power even at 50 degrees ambient temperature without derating. And in terms of the temperature within the inverter, because of both the active cooling and the double wall concept, the components of a Tauro inverter are kept at about 13.5 degrees Celsius lower than comparable inverters of similar size. So that means that you can expect a full service life out of the Tauro inverter, because as we know, for every 10 degrees increase in the operating temperature of an electronic component, you actually would cut the life by half. So these two concepts, both the active cooling and the double wall concept, mean that the Tauro inverter is going to live out to the full design life. So in terms of wiring, let's quickly look at wiring, what is required. So this is also that information that was covered briefly also by Byron. So you access the connection area for both AC and DC. So the AC connection area is to the right, and then here to the middle, depending on if you have a pre-combined version, then you would also have the access for the V clamps. But for connection to a direct version, then below the inverter here, you would have the connection for the MC4 plugs. So when you're going to do the opening of the front cover of the inverter, just ensure that the DC connectors are in the off position, and then you can proceed with the removal or opening of the cover. And if you have an AC disconnector also installed in the inverter, ensure that this is also switched to the off position before you continue on with wiring activities of the inverter. So when wiring a Tauro direct inverter, you will have a connection for as follows. So this information was already shared, so I will not go over it again. So for distribution of power, when you have a Tauro direct, so this is an Eco 100 kilowatt inverter. So we can see that the power is actually divided into three PV inputs. So we have PV1, PV2, and PV3. And the recommendation when you are wiring the Tauro 100 kilowatt, for example, is to start wiring from the odd inputs. So in this case, we have, for example, 1.1, and then you would go to 1.2 for the next PV input. So you start with PV1, you go to 1.1, go to PV2, you start with 2.1, go to PV3, start with 3.1. So this ensures that you have equal distribution of power across the three PV areas or the DC input areas. So once you have filled all the odd numbers with the string power, then you go ahead and fill the even numbers out. So it's important not to mix MC4 plugs from different manufacturers. And we do recommend the use of only certified MC4 plugs, like what is inbuilt in the Tauro, which is a Staubli MC4 plug. So in terms of the currents that can be connected to the inverters, so we have currently a trend whereby solar panels are coming out with even higher output currents. So the best option when you have PV modules with high currents would be to use the Tauro pre-combined, as this is not affected by the output of the modules, as the current is collected in a DC combiner box. But if you want to go with a direct version, then ensure that the fuse selection suits the IMPP, or the maximum power current of the PV string. So when you have current up to 22 amps per string, then it is recommended that you go with a different fuse. So as already mentioned, for the Tauro direct version, you can choose between a 20 amp or a 30 amp fuse. So initially, when we had the standard M3 and M4 solar cells, so these were the 159 and 162 millimeter cells, this would give out approximately 9 amps, but the trend continued to rise. So it develops to M5 and M6 with about 165 and 166 millimeters. And the approximate current at maximum power is about 10 amps. But currently we do have the high power modules with the M10 and M12 solar cells. So these are the 182 and 210 millimeters that can give out a maximum of 18 amps. So depending on which module you're going to use, then you have to make sure that you either go with a pre-combined version or make sure that the fuses selected for the particular Tauro inverter are going to be compatible with the output power of the string at maximum power. So in terms of the DC wiring of the pre-combined, so this was already mentioned, just quickly repeating this information. For the 50, 99, and 100 kilowatt Eco version pre-combined, you have 4 usable cable glads. So therefore it means you can connect 2 direct sources from DC combiner boxes. But for the Tauro 50 kilowatt with the 3 MPPTs, you have 6 cable glads. So therefore you can connect from about 3 DC combiner boxes. So within the inverter, of course, you have the V clamps, so it makes it very easy for you to connect the power from the DC combiner boxes. So in terms of the permitted cable cross sections, we have the Fronius Tauro 50, that is with the 3 MPPTs, and the Tauro Echo 50, 99, and 100. When you have the direct version, you can go with the 2.5 up to 10 millimeter square. This is the direct string connection. And if it's the pre-combined with the V clamps, then for DC power connection, it can be anywhere from 25 to 95 millimeter square. So the only note here is that, especially for the pre-combined, ensure that your DC cables have a temperature tolerance of up to 90 degrees Celsius. If not, you can also order cable protective hoses from Fronius that would ensure that the insulation of the cables within the inverter connection area is not affected. So in terms of the AC connection, also to give you some highlight about the V clamp that is integrated for AC power connection. So you can connect anything from 35 millimeter square cables up to 240 millimeter square. So, and cable lugs are only required for the protective earth. So when you have a cable cross section of 185 to 240 millimeter, the profile of the V clamp looks as shown below. And if you want to connect a smaller cross section from 35 millimeter to 150 millimeter square, then using an Allen key, you can adjust the position or the profile of the V clamp so that it's able then to anchor on to the smaller cross section cables properly. In terms of the choice of cables, I think also just to give you information on what is allowable. So only use these cable types for the V terminals. So we have the RE solid route connectors, as you can see them here. We have the RM, so these are the route stranded connectors, as you can see them here. And then the SC, the solid sector connectors, and the sector stranded connectors. So if you're going to use cables with very fine strands, ensure that you use ferrules at the end of the cables, and this ensures that you are not going to have, by accident, some of the strands touching onto the next phase of the connection. So for the AC connection area, in terms of cable cross sections that are possible for the 50 kilowatt versions of the Tauro with 3 MPPTs and the Tauro Echo with 1 MPPT, you can connect 35 millimeter square up to 240 millimeter square. And for the Tauro Echo 99 and 100 kilowatts, you can connect 70 up to 240 millimeter square. So just like for the DC connection area, ensure that the cables that you have selected have a maximum tolerance of temperature of above 90 degrees Celsius. So if not, you can order the protective hoses from Fronius. Here is the article number, and this ensures that you increase the temperature resistance of your chosen cables. So at this point, I would like to engage you in a small exercise. So we will do a simple Menti question just to relax our brains a little bit. So, and for this session, we require to use your phone, and we then eventually will require your feedback on the question that is asked. So in terms of what is needed, you have to scan this code with your phone. And once you scan, it's going to take you to the next phase where we will ask you the particular question that we want to interact you on. Okay, so I think, Cyprian, you have to take over and do the question because I think my link is probably broken. So I'll hand over to Cyprian so that he can redo the launching of the question and then he can continue with his part. Cyprian?
Yeah, hi, David. Yeah, thanks a lot for your wonderful presentation. I'm getting some questions, or some complaints on the questions tab that they can't access the question. Okay, so I will try to. So first of all, let me show my screen. I believe you can see my screen now. So let's see if we can do this again. So for the attendees, we're going to try this again and see if you can access the login code per se. So so all you need to do is to scan this code, or in case you're not close to your phone, you can of course open a new tab on your PC or whatever you're using to attend this webinar. And then all you need to do is to scan this code or log into this website, www.menti.com. www.menti.com. So if you're able to do so, you will be required to impute a code. So this code is 25455471. 25455471. Good. I can see that people are logging in, which is really nice. So we have 3 attendees so far, or participants for this particular exercise. So it's now increased to 4. So please, if you want to use your phone and you have the scanning app, you can easily scan this app. It will take you straight up to the page or the room where we're going to have this brief discussion or exercise. So the number has come up to 7. Let's see. I'm going to leave it for a couple of seconds so that we can continue with the rest of the presentation. So we have 8. That's a very good sign that we have more people logging in and more interest being garnered. David, I would like you to be on standby because probably we might discuss the result of the Menti question together once we're done with the exercise. Okay, so we have 9 or 10 now. So I will leave it for, say, 15 or 20 seconds, and then we can now continue with the Menti question. Yeah, so this is basically an exercise to sample your opinions about a particular aspect that has to basically do with renewable energy, system design, use of some components in design or some component design software or application. So for this, we have decided to choose a particular question to sample your opinions and what you feel about it. So I will now continue to the question. Thanks a lot for the likes. I'm getting, we're getting wonderful thumbs up. So that is an indication of the appreciation of this exercise. So we shall now continue. So not to worry, even if we go out of this page, you will still have the code, the barcode to still log in or scan and then log into the questionnaire. Good. So the question is, what do you consider to be the most important attribute when selecting a commercial PV inverter? Like I said, the code is still here. You can still scan the code and then log in. The question again is, what do you consider to be the most important attribute when selecting a commercial PV inverter? So I've had responses already. So the options are weight to power ratio, ease of installation, return on investment, ease of service, and inverter cost. Okay, so it is obvious that, okay, we're getting several responses, most going for return on investment. Wow. Equal number or percentage going for ease of installation, ease of service, and inverter cost. And none for weight to power ratio, which is quite interesting. Probably might form the topic of discussion immediately after this poll. So we have, oh, great. So we now have one that percentage going for weight to power ratio, 5% so far. Yeah, this is really nice. Thanks a lot for the varied response. So it goes a long way to show that there are certain criteria or features that we take into priority or into most concern when designing or selecting a commercial PV system. So we will end this now, and yeah, we're going to briefly discuss the result. David, if you're on, please, could you turn up your mic so that we can briefly discuss this?
Yeah, thank you, Cyprian, for the support.
Yeah.
And I think this clearly shows that, like you've mentioned, there is a clear criteria that installers or developers of PV systems want to use when selecting a PV inverter. So as you can see, the highest percentage, which is 60%, is on return on investment. Which I think is very valid, because that is the objective, that you have asked your customer to invest in a certain amount of money for this particular system, and you have made some guarantees that within a certain period we will recoup the investment that you made on this system. So I think this is a very important criteria, and so to say, the Tauro is designed on maximizing the return on investment when you consider both the capex and the opex, which, as Byron mentioned, would actually equal out to the total cost of ownership of the PV system. So I think our attendees are really up to it in terms of what they consider to be the most important attribute.
Yes, indeed. And what do you now think about the first option here, that weight to power ratio? Because sometimes we usually get the impression that some installers or site engineers or design engineers tend to go for products with higher power density, but then lower weight to ratio feature.
Yeah, I think it's also
in comparison to Fronius advice. Yeah, go ahead.
Yeah, I think it's also indicative of which features are integrated into the inverter. So, like with the Fronius Tauro, for example, you have the double wall concept, and also in addition to that, we have the active cooling technology. So that in itself might slightly increase the weight, so to speak. But in terms of the yield guarantees that you get from this kind of design architecture of the inverter, the Tauro sort of almost guarantees that under any circumstances or operating conditions, the yield is going to be optimal. And therefore, the return on investment, as being an attribute that is most attractive, can be guaranteed with the Tauro inverters.
Great. Thanks a lot, David. And then thanks once again to all the participants. This shows that you're actually up to it in terms of system design and selecting of suitable commercial PV. Thanks again for all your contributions. Thanks, David, for your insight as we continue with the presentation. Good. So I will be continuing from this point, the presentation, with design tools. Of course, there are so many design tools out there, but then there are specific ones that are kind of supported by Fronius, or recommended per se. So this could include PV Sol and PV Syst, but then we have a design tool, Fronius design tool, which is called the Fronius Solar Creator, that can be used for basic system design. And of course, this can include the Fronius Tauro. And of course, it has also all the possible design calculations included in it. There are also other design tools like the PV Scout, Plan for Solar, Polyson. But then it is pertinent to point out here that the design criteria, due to the different inverter data that are used for the calculation, might make the outputs or the results you might get from these other tools not as accurate as possible. compared to the case of PV Sol and PV Syst, where all inverter data are always up to date. Going forward, just to tell you more about the Fronius Solar Creator, it's basically a web-based, free-to-use, user-friendly configuration tool that can be used to comprehensively design and simulate photovoltaic system in combination with other sectors that can be integrated, including heating or generation of hot water, charging of EVs, and of course, storage systems. Good. So when it now comes to talking about Tauro strictly now, when it now comes to correct string design, there are conditions that are supposed to be met in terms of designing for the optimal DC voltage per se. Well, in Fronius, in all our inverters, we have with the exception of the Echo, we have buck and boost circuits that helps to complement the input voltages in the case where we have interruptions or fluctuations for whatever reasons. So what this complementary feature does is to, in the case whereby the voltage is low, well, say from lesser than 300 or from 300 and above, the booster circuit comes on. And then once it's able to achieve rather say an equidistant voltage per se, or an equilibrium voltage, which is usually in the range of 595, between 566 and 595, then the buck circuit comes on, or basically the booster circuit goes off. So that's what basically happens. So all this in the process of ensuring that we have an optimum DC input voltage with our inverters. That is why it is possible to have the inverter come up and running and functional even with low irradiation. Good. So going forward, we're going to talk a little about the data communication. Well, for data communication, what we use or what is implemented to achieve data communication is a data communication module, rather called the pilot. So the pilot, it comes embedded with so many features, including LED status indicator, also serves as a data logger, web server, and LAN interface, either hardware or wireless. It can also help in visualization via Fronius Solar Web, and also comes with numerous open interfaces, including Ethernet, that is LAN as mentioned earlier, two Modbus RTU interfaces, the WSD function, which is the wired shutdown function, which I'll be shedding a little light on, and then we have the digital inputs and outputs. So with the wired shutdown, it is possible to shut down the system via this switch. So this switch can be wired to a normally closed switch, or the emergency switch, as we all know. So once this switch is triggered, all the circuits connected to this switch will be turned off. This comes in very, very handy in emergency situations, say like fire incidents. So if there's fire on the roof per se, where the where the panels are installed, it is possible to quickly and semi-remotely, I would say, turn off all the inverters with this particular switch. And then the maximum distance between two devices is given at a recommended 100 meters. And then the maximum amount of device per switch connection is given as 10. The wired shutdown terminal actually comes bridged ex-factory. So all you have to do is to open the bridging and then connect the in and the out respectively. Okay, so continuing, we're just going to give a brief about the Fronius smart meter, which is a bidirectional meter that can be used to, very importantly, give access to analysis, data analysis and visualization by making it possible to access both consumption and production details. Of course, like I mentioned, it's a bidirectional or two-directional meter, meaning that you can have access to what is coming into the system and then, of course, what is going out of the system. It comes in single-phase and three-phase models. We've just, for reference purposes, we've decided to just have, and for time constraint, of course, decided to just show you what the three-phase looks like. This used to be the old version per se, but it's still in use. And then this is the new version. But then, of course, the functions remain the same. So for the old version, we have it in the 50 kiloamp power capacity. That is for the commercial Fronius inverter and Fronius smart meter model. We have the new one, the new smart inverter TS. TS here stands for touch screen, so you can actually use the touch screen features to do your configuration. These you can see beside the smart meters are all CTs, so you can, of course, with the current or the ampacity, of course, it we hope that there has to be a current transformer to bring down this large currents to usable or friendly currents, which comes in the range of 1 or 5 amps. It is also possible to make use of another new type of CT that was rolled out a couple of months ago. It's called the Smart Meter IP. So this is somewhat a voltage-based CT. Okay, so this also comes in the 5 kiloamp capacity. Good. Connection. This is how it's wired, of course, with the use of CTs to bring down the currents to friendly currents, as I earlier mentioned. But most importantly, to take note is the connection from our smart meter to the pilot. So ensure that you have the correct terminals connected. That is the A, B, or D plus or D minus, as some installers would understand it. In our own case here, according to the terminology of the Modbus, it's titled M0 and M1 because we have two Modbus terminals, so you could either use any of them. Depending on the one you make use of, please ensure that the switches are on. As if you look closely, this is for the WSD switch. Now, next to the WSD switch are two switches. That is for the MB0, that is Modbus 0, and then Modbus 1. So depending on the Modbus you want to make use of, you can turn the switch on by turning it to position 1 or just turning it to the right-hand side. So turning this on, what it actually does is to activate 120 ohms looping or terminal resistance embedded or integrated inside the pilot. Same is done also on the smart meter end, because with the smart meter, in order to complete the communication loop, there also has to be terminal resistance connected on the smart meter end. Now, to achieve this, you don't have to connect any physical resistor, as it used to be the case with the old resistors, the old smart meters. So what is done these days with the TS, the new smart meter TS, is to loop certain terminals. For the single phase, there are terminals already designated to be looped. For the three phase, as you can see in this case, all that is needed to loop is terminal 10 and terminal 12. So once you do this, you have already integrated the 120 ohms resistor that is already inbuilt inside the smart meter. Good. So continuing, we're going to talk about briefly about the cable selection for data communication. So there are generic cables that are used for data communication. but most especially for LAN communication, if you all know that it's usually deployed using TCP cables. So, but then for Modbus, RTU, input output, and WSD, it is recommended that we go with at least 1.5 mm squared. I mean, maximum cross-sectional area of 1.5 millimeter squared of a cable. For the LAN, that is usually TCP, Modbus TCP based. This comes usually in the standard cable gauge of between 0.35 and 0.75 mm squared cable cross-sectional area. For the maximum cable length for LAN is 100 meters. For Modbus RTU is 300 meters. For input-output connections, single ladder is possible, but with the maximum cable length of 30. And then for the WSD function, as I mentioned earlier in the previous slide, is 100 meters. Good. Now let's talk about interconnection of multiple towers. So this is possible with the use of a LAN switch. If for those that recall, for all our snap inverters, we make use of what is called the SolarNet ring, which basically consists of the ring topology, where the input of one inverter, data communication wise, is connected to the output of the next inverter for multiple inverter cases. But then that's not the case for Tauros. So for Tauros, we have implemented the star topology, meaning that they have a high degree of independency communication wise for all the inverters, as you can see. Good. Before I continue, it's of course important to mention that there are 2 LAN ports, as you can see. So, but then it is recommended that you only use LAN 1 for such purpose. LAN 2 is actually designated for internal use only. Good. So going forward, this is basically how it would look like. So you can connect directly to the LAN switch. And then in a case where distance becomes a challenge, so for further distances beyond 100 meters, you can now have a repeater switch that you can now connect other inverters to, as you can see in these other cases. Good. So, like I've mentioned before, it's a star topology that we've implemented. So you can, of course, make use of power over internet switches, PoE switch, and then this would enable you to achieve a multiple connection of towers. Good. Yeah, another very good feature of the Tauro inverter is the provision of enough space for third-party components. So if you look closely, it is important and very applicable here to have third-party components installed. So meaning that the PoE switch, as I mentioned earlier in the previous slide, can, of course, there's a possibility of having it installed in the space that has been provided here inside the tower. And then doing this, of course, accords this switch an IP65 protection, meaning that it, of course, would enjoy the same protection as every other internal components inside the tower inverter. Now, for export limitation, this has actually come as a very, very important and burning topic amongst installers because it is, of course, important to implement export or feeding limitation, as we would understand, because of conditions being set out by the grid operators. And yeah, it is my pleasure at this point to introduce to you what we call the system power control feature of Fronius. So this is actually a new feature that makes it possible for interoperation. By interoperation, it means it is now possible for different types of Fronius inverters to operate per se. By interoperability, we mean we have dynamic power control of mixed systems greater than a single inverter, as you can see already illustrated. So this means that you can combine snap inverters, Gen 24 inverters, Tauros, and a maximum of one Gen 24 plus. That is, the Gen 24 plus is Fronius hybrid inverter connected with the battery. And then, so you can go as far as 60 inverters for one system. And the communication protocol between the inverters is the Modbus TCP. So with just one smart meter, you can be able to achieve interoperability between all these sets of inverters. And this, I tell you, is a wonderful news. And that's not it. The best part is that it comes as a software update. So all you need to do is to run a software update, and then you can achieve interoperability between various brands of inverters across board. So going more into it, before now, this is what used to be the case for Gen 24 inverters and snap inverters. Depending on the branches, you needed multiple smart meters. So take, for example, this particular setup that has two branches, two secondary branches per se. You would need a primary smart meter and then smart meters for the respective branches, as you can see. So either that, or you can now make use of a plant controller. With the Tauro, only the plant controller solution was possible, as would also have been experienced by our installers. And this, of course, costs extra money per se. And so that was the case until now, that we now have, with the system power control, the possibility of controlling all the devices without any additional hardware needed, only a software update. And just to add here that in a case for a system where you have a Gen 24 plus inverter with a battery, so that particular inverter connected to the battery would now be the master of the system. So basically, the pilot, which is the communication module used for both Tauros and Gen 24 inverters, what you would be able to use to implement this system power control. Good. Just to add, basically a summary, you can use it to achieve dynamic active power reduction and control of multiple inverters from basically more than one to up to 60. You have one master, and the master must be a pilot device. And then, in the case where you have solar net, that is, you have light inverters included inside the system, there is a limit of 4 light devices per solar net ring, as you can see described here. That's very good news. So let's continue to the initial commissioning process of the Tauro. Well, it's basically straightforward. This can be achieved by going through the settings and then, of course, accessing the Wi-Fi access points of the inverter, and then going through these 3 basic setup: the network setup, the product setup, and the SolarWeb setup, and you're done. So just to put it in perspective, all you need to do is to download the SolarStat app, open it, and then access the Wi-Fi access point of the inverter. And the process is basically step by step. So all you need to do is just to follow these steps, and then, of course, you will not go wrong at all. So it is also possible to achieve real-time monitoring of all your systems via SolarWeb app. So it is possible to access the system, find out what is happening in the system, and also carry out active actions on these components in the system. Processes like firmware or system updates, you can actually do that via the SolarWeb app. And of course, with this app, it means that You don't have to schedule any appointment or necessarily drive all the way to the site to achieve this. So this is completely, this is achievable completely remotely. Good. In terms of service and exchange of components, which is a part of what we were discussing with David earlier during the Mentimeter session. Yeah, it is possible to achieve component exchange, like the power stacks, for example, as you can see in this case. So there isn't any need for a total replacement of the whole inverter. Because of the modularized nature of all our inverters, it is possible to carry out component exchange. So if anyone has any component has any problem, all you need to do is just to exchange that component. And for the power stack, for example, it weighs just about 25 kilograms, which is possible for one person to handle. Yeah, so this of course goes a long way to save on OPEX cost. Very, very important. And please, once any correction, once any replacement is done, please always remember to turn off before and turn on after services have been rendered. And to mention here that part of what gives the Tauro the advantage is that once you're able to achieve a seamless ease of service, it of course goes a long way to boost the return on investment because of the reduction in OPEX cost. So also important here for the Tauro is another app, which is called the Solar SOS. This is basically a troubleshooting app that can be used by all our installers to achieve troubleshooting processes, ordering, case overview, access to manuals, and of course, reception of automatic notification in the case of service processes or cases. So this makes it absolutely possible for the trained installers to be able to carry out what you might call first aid services to whatever system that pops up with an error code. So without necessarily calling up on the tech support, because all the processes are actually self-explanatory. And then, like I mentioned earlier, this, of course, the training for this is always offered by Fronius to all our installers, so they are equipped with the knowledge to carry out this process. Good. So after having said this, we want to believe that you have been equipped with all the necessary information needed to make use of and, of course, design a system with the Tauro inverter. So, which leaves the question to ask if you are already ready to make your order and with the Tauro configurator. The Tauro configurator is a free app, web-based app that can be used to make your order. For time constraints, I might not be able to go through all the features, but then just for a demo, this here is an active link that you can actually use to gain access to the app. Yeah, so once you click on the link, it will take you straight up to the app where you can be able to design your system using the Tauro configurator. All you need to do is to click on Start. It would you will have a prompt where you select what kind of system you want to design, if it's a centralized system or a decentralized system. Make your choice. If you don't have any idea about what the centralized or decentralized system means, you can click on this information and you will have extra knowledge, summary of what they entail. Click on Next once you have selected a particular system. Click on any inverter at all you want to make use of. It will give you information whether you can apply fuses or not. So for P variant, you cannot use fuses, but for the D variant, you can. Just to buttress on this point, if you decide to go with the D variant and then make make your choice of inverter, you can see that you now have the option of making including fuse. This is because all the modules are connected directly, all the strings are connected directly to the inverter. So you now have to implement the fuse, string fuses. So make your choice of fuse, choose whether you're going to make use of the AFCI feature or not. This is connected X, it's integrated X factory. It cannot be done X factory. So you have to make your choice during this configuration process. So if you select it, it will now take you to the SPD pane, where you now select which of the SPDs you want to make use of, type 1 or type 1+2. If you go with type 1+2, meanwhile, the functions are there for both type 1+2 and type 1. You can see them here, what protection it provides you. Once you do so, it will now take you to the AC connection point, where you'll select if you want to make use of the AC daisy chaining feature. If you're using single core cables or multi-core cables, select whichever one you want, and then select if you want to implement it an AC disconnector or not. So once you make that, it would now make your configuration available for you, as you can see, where you now have the opportunity to indicate how many, the quantity of inverters you want in this particular configuration. Next point is to title your project. I'll just quickly title this as Tauro. And then you can now choose from these accessories either to implement, if you want to connect them horizontally, that is facing upwards, you can make use of floor mounting racks. You can also make use of protection hoses for insulation, and then DC locking device, interlocking device to prevent unauthorized operation. So once this is done, you can now select whichever way you want to export your configuration. If you want to export it via email, you would have your email prompt pop up, and then you can now send this all the way with your chosen configuration, as you can see. So basically, this is how you can achieve a system setup using the Tauro configurator. Sorry, I was a bit fast in this, but then there are dedicated webinars that cover these topics in very, very good detail. So with this, we have actually come to the end of the presentation for today. We hope you appreciated the content of the webinar. So just to give you further information about our recordings, they are available on our homepage, where you can get operating and installation instructions. Webinars recordings are also available on our YouTube channel, where you can have access to all our how-to and installation videos. In particular, for our sub-Saharan, we have a sub-Saharan Africa playlist, where through this link you can gain access to all the webinars that have been published so far, including this one. Good. So yeah, for other inquiries, be it technical, training, after sales, please do well to contact various departments via this contact details. If you want to have access or contact us, the TSAs, please do so according to the TSA responsible for your region. Myself, Cyprian Okolo for the Western Africa region, Byron Kotzer for the Southern Africa region, and David Mwangi for the Eastern Africa region. So thanks to you all for finding time to attend this webinar. We, of course, appreciate this, and looking forward to your orders for your Tauro inverters. And until we come your way next time, this is saying enjoy the rest of the day, and thank you once again for attending. Bye.